Good morning, welcome to this session. I will talk how manufacturing applications are deployed and running on OpenVMS with the manufacturing at Volvo cars. My name is Toine Dirven. I'm head of manufacturing digital solution and architecture and design within Volvo cars. So making sure that we have the best solutions within our plants to assemble our components like engines, batteries, but also how to assemble our cars in our plants worldwide. And the idea is that we try to have the same application in every plant so that we have standardized setup, and we are still using quite a lot of OpenVMS in every plant. There are a lot of slides, so sometimes I will go quickly. If I'm going too quickly, you just say stop, we can't follow you anymore. This is the agenda, a little bit what is Volvo cars, so that you get an idea what we are doing. You know, we are a car company, but I will only focus on the manufacturing part, not on sales or R&D, only the manufacturing part. I will show you a little bit the OpenVMS infrastructure that we are using within Volvo cars. And also I will tell a little bit about Java. We are deploying quite a lot of Java applications on the OpenVMS platform on integrity and also testing it now on x86, and I will do some comparisons. And in the end, I want to show a little bit how we integrate our OpenVMS platform with other platforms that we are using today. So not all applications are running on the OpenVMS platform, also Kubernetes platforms are coming, and you also know not all databases are available yet on OpenVMS. So for example, Oracle is still running on Linux in our environment. For Volvo cars, we are producing these cars at the moment. We have plug-in hybrids and we have full electrical cars. But since 2020, Volvo cars has decided that all new models should be fully electrical. But what we are seeing is still that customers also want hybrid cars. So what you will see, the hybrid cars that we have on the left side, we will still produce a bit longer than planned. But all new development is going to the full electrical cars. And then you have the EX40, EM90. EM90 is only for the Chinese market. EC40, EX90, and the latest one that we released was the ES90, and also a smaller car, the EX30. And the other ones are cars that are already longer in production, the XC90, XC60, XC40, and the sedan versions as well. These cars are produced in Europe, in the US, and in China. And we have a little bit knockdown operations in countries where we have high import taxes. So here you can see where do we have manufacturing. We have it in Charleston, in US. Perhaps I should show here. We have it in Charleston. We have a factory here in Tuslanda. It's 2 hours drive from Malmö, or 3 hours. We have a factory in Ghent, in Belgium. We are building a new factory in Slovakia, in Košice. Yeah. And then we have component production. We are stamping material in Olofström, that is also here in Sweden. In Floby, we have installed a new line to build electrical engines. It's also in Sweden. And then in Bangalore and in India, we have KD operations, knockdown operations. We are sending cars with parts to it, and they assemble to the final assembly in these plants. It's our small facilities, but it's to reduce the import taxes. And we have the same in Malaysia. Then in China, we have 3 plants. The first one was in Chengdu. Then we installed the second plant in the north of China in Beijing. That's almost close to Russia. And we have also a plant in Daizhou. It's just below Shanghai. So when in all these plants, we are running our MES application, our manufacturing execution system. We are running that on OpenVMS. So in every plant, you have local installations of an OpenVMS server running the MES solutions, but also the material handling solutions are hosted on that platform. So material handling are the logistics solution, making sure that all the material arrives in time at the production line. If you look to a car plant, we have a welding shop where we do the welding of the car. In every welding shop, we have around 900 robots. And we communicate most of the time to the PLCs, and the PLCs are communicating to the robots. So if we have to send instructions from the OpenVMS platform to a robot, we most of the time send it to the PLC, and the PLC is forwarding that to the robots. For example, in the paint shop, the PLC will ask, please give me the color of this car, and we will answer in less than a second, and then the robot knows what to do. Then in the welding shop, we have around 5,000 spot welds, different welding points per car. But I will go for this a little bit quicker. Then we have the paint shop. I told you the welding shop is a fully automated shop. The paint shop is more a process shop. What does it mean? We have to make sure that the humidity and the dust is always on the same level, so that the paint production, well, when we paint the car, that we always have good quality. And then a lot of people are also checking the cars. Is the paint really good on the cars? And we also follow up paint issues in our quality system, and later on more about that. Then in the final assembly, that's more a people shop. So I said the full automated shop and the welding shop, the process shop is more the paint shop. Then in the final assembly, there you have around 2,000 people working per shift, and they have to make sure that we put all the material in the car, the dashboards, the seats, the bumpers, and connect everything, and then follow the instructions, and also bring the material to life. If you look in the final assembly, all the different car models are built on the same line. For every car, we have a customer order, so there are unique orders per customer. And within the logistic area, we bring around 3 million parts to the production line on a daily basis. So at the production line, you need your parts to install that in the car and also connect it. And the speed that we are running is, let's say, 1 car per minute. So every minute we have a car that is factory complete that can be shipped to our customer. And the production is 24 hours a day. So the difference between 24 hours production or 2 shifts, it's a big difference. You have no maintenance windows, and that's a big difference. So to run operations just in 1 or 2 shifts is much easier. You have time to do maintenance, to fix. When you are running 24 hours, it should always be running fine, and you have to be able to install applications without any downtime. Then here, this is the battery plant. Like I told you, we are going to more full electrical cars, and now we are also assemble the batteries in-house. So that's a new process, but that process is also steered by our OpenVMS servers. Then if you look to the EDU plant, so we have a new plant in Floby here in Sweden. On the right side, you see the electrical engines that we are producing, and on the left side, you see how the electrical engines are put into the car. And we have a new electrical engine plant in Sweden, in Floby, and another one in China, in Taizhou. Now we come more to the how do we follow up our production. So on every car, you have an RFID. So on that picture, on the right side, you see a small plastic RFID. So on every car, we mount an RFID, and that is used then to identify the car. And we track the car in the complete shop. So we have RFID readers around 100 in the plant, so we know exactly which car is at which position. And at certain positions, we have to take a decision. Should this car go to a repair area, or should this car to the next station, or should this car, for example, in the paint shop, sometimes you have 2 colors, should it get the second color on the roof? So the RFIDs are used to identify every car and also to send the correct instructions for every car to the installations in the plants. And I told you all the instruction that we are sending to the equipment is always going via the PLCs. We have quite a lot of Siemens PLCs and still also a lot of sub PLCs from a company in Malmö. And we have around 100 PLCs that are communicating all the time with our MES solution. And then the response times, we always say, every request should be answered in less than 1 second. I must say now for the EDU production, we got a requirement for 200 milliseconds, but sometimes I think less than 1 second is sufficient, but then they really want high speed. If we look in the plant, at every workstation in the final assembly, you have a small PDA. When an operator is coming to the workstation, he takes that PDA and he has a small application of the PDA called DAISY. and DAISY stands for Direct Access and Information System. So he will scan, I start to work, he scans this batch, I start to work on this workstation, and I start to work on this car. So a person is working 8 hours a day in a shift, and every 2 hours they change workstation. When you are working on a moving line, it's also nice that you every 2 hours can work on a different station, and that's why we have these DAISY stations, so that they can identify themselves on which car they are working, and also when they change to another workstation. Also with that application, they can call off material, and they can also say, I need support. Sometimes it can be they can't mount a certain part, they can call for help, and then the team leader will be informed and supporting. That's a more an Allen-based solution. If you look down, we have 400 concurrent users using these PDAs. So we have a small web application on the Android device, and on the VMS environment, we have 4 processors supporting that. So you see you have quite a lot of users, but when you have a proper application server, you don't need a lot of processors on the VMS environment to support all these end users. Then material handling, I told you, we also have to bring a lot of material to the line, and we have around 300 people driving around with forklifts and tuggers to bring the material to line. And on the left side, you see the user interface for these material handling people, and then also here you can see we have quite a lot of users using the material handling solutions, and I'm bringing the material to line, and then it's quite a nice solution supporting the logistic department to bring the material to line. So I told you 3 million parts, so it's a lot. In a car plant, we build cars, but the logistic flow is almost the biggest part. We always want to have as less stock as possible, so all material arrives just in time, not too much stock. And that's why we need quite some people to bring the material to the line. And you have only place for 1 box at the line, so when it's almost empty, the second box should come, or the second pallet, or the second rack. But we have also some material that is coming from not close by, from China. So some material we store also. You know, we get material from China. It's going via the Suez Channel. Sometimes there are some fights ongoing, so now the boat has to go further via South Africa. So we also store some material in our automatic warehouses, and also these automatic cranes for boxes. And for pallets, they are also steered by the by the solutions running on the OpenVMS platform. Then in the plant, we have also quite a lot of nut runners. So we have 500 nut runners. They are used to connect every bolt to the car. But for every nut runner, we have to send a recipe. So we have to say, when a person is taking his nut runner, standing for a certain car, we say, okay, you have to connect for these car 3 bolts and with these torque values. When the bolts are connected, we get the feedback. So you see that a person working on the line, he can work on 3 cars at the same time. When he's in front of the car, he gets the correct instructions on the screen. He's connecting the bolts, and we get the feedback. Because for every bolt that is connected on the car, we keep the information for 15 years. So let's say there is an accident. We have to prove that the car was built correctly. So with the correct torque values, and that also the direction of a bolt is also correctly. When you try to connect the bolt and you do it wrong, then it looks like it's fitted, but then it can be like you have your steering wheel. If the bolt is not going in the correct direction, it can be that you're driving your car, you want to go to the right, but your car still goes straight on. So you have to prove that every bolt that you put in the car is connected properly. And that is also steered by the application running on the OpenVMS platform. Then for the quality, so we also follow the quality of the car, the welding quality, paint quality, battery. We are using a system called ATTAC. It's also hosted on the OpenVMS platform. ATTAC stands for Answer to All Car Questions. And then an operator can say, I have an issue, a paint issue, this is for the paint job on the car. So they select the quality item and put it on the position of the car. And before the car is leaving the paint shop, this should be repaired. Let's say they have a paint issue, then they have to repair it before it goes to the final assembly. And no car will leave the plant with any open quality issue. So we can't ship any car to a customer when there is still an issue with that car. Yes, then something about the OpenVMS infrastructure, what we are using. So in total, we have around 30 integrity servers running OpenVMS, the VSI version. It is a combination of BL860s and BL870s we also have, and also some rack-mounted servers, RX 2800s. And we are also testing x86, and that we are running today on a VMware platform. Yeah, I don't know if this interest for you within Ghent. We have in Ghent, the plant in Belgium, we have some blade servers. This is the setup that we have. We have a cluster of 6 nodes in production, and in the development environment, we have a cluster of 2 nodes. And that's then an i6 server and an x86 OpenVMS server. And in QA, we have 1 test server to do quality assurance testing. And we have 1 server for the monitoring. We use Cockpit Manager to monitor our complete environment. In every plant, you have a production environment where you have also a QA server to test application changes. And so when we develop our applications, I told you we have a lot of Java applications. The developer develops his application, he tests everything in the Azure cloud. When it is ready, he runs a pipeline and automatically the new releases are deployed on QA servers in all countries. So it's not that you have to log, they don't log on anymore to the VMS environment. They just say, now I have a new release, and they release a Java application. The only thing that needs to happen is to restart the application. So it's, yeah, the developers are happy with the way of working it. Our young people, they want to develop on the PC, they want to use co-pilots, but then what we have made sure that we have proper pipelines from Azure DevOps to our OpenVMS environment, and that's how the applications are deployed today. If we continue, yeah, this is a little bit how the setup is, which versions we are using, how the cluster is. Then this is our development server. I told you we have 1 integrity server with 8.4-2 L3 and 1 x86 server with version 9.2-3. And on that server we are now testing our applications if they are working correctly. And then the next step is to move also production to x86. This is the cluster in Gothenburg, in Torslanda. And this is, but I think, oh yeah, and this is also what I would like to mention. I have had quite some issues with hyper-threading. If you enable that on a server with more than 4 cores, your system will be really slow. A lot of people think you should enable that, but please disable that because your NP sync on your service is really high and everything is slow. So if you have, for example, 16 cores in your server, don't enable threads on your CPUs on the console. What is happening a lot, sometimes there's a firmware upgrade and by default it's enabled. And then you think, why is this server so slow? And then we see, okay, by accident it was again enabled. So disable your threads on your CPU. So if you go to the console, you can put it off. I don't know, are you familiar with it, or is this all new for you? Or are you familiar with the console and enabling, disabling threads? Then we have our environment in China. There they are using a combination of blade servers, also some rack-mountable servers. And then in Beijing, there we have our biggest server. We have a 700 gigabyte RAM memory and 32 cores. So that's in the north of China. They have quite a large environment there. Then something about the database that we use on OpenVMS. We are running around 30 RDB databases in Ghent and also in Gothenburg for some tests. We are running Nemo databases, mainly in the plant in Gothenburg, Torslanda. And then in all car plants, we are using Opera90C for our MES solution. And the setup of Opera is a data card setup. So you have an active database and a standby database. If you are using that setup, it's also important, I showed you there, that you have a dual connection string, so that you connect to your, that you in your tool connection thing, you say, this is my active server and my standby server. In case the active server fails, the standby server will take over and you don't have to restart your application. And you have to make sure that your connection thing that you use in your DNS names or in your Java application that you define it in the correct way. Yes, and something about Java on integrity and x86. At the moment, we are using version 8 of Java, and this patch level, I've seen there is now a more recent release from VSI, but at the moment we are testing this on the integrity, and I also are comparing it now how does it work on x86. And what you see is, if you see the versions, it's the same version of Java on integrity as on x86. But we have also seen now we are waiting now for OpenGDK version 17, and I saw on the VSI website it will be released in December. But if we could have a field test earlier, would be nice. These are the products that we have installed on x86. Availability Manager, the C compiler, curl, C++, DECnet. Yeah, so the fourth one, we still have some popular applications, not so much anymore. OpenGDK, OpenSSH, SQL Relay Server, since Open is not available yet. We are also verifying if we can use SQL Relay Server. We are using vgit to go to the Azure DevOps repos, but we want to replace that with a new Git product that is also released by VSI. Then, all Java applications running on integrity, what we have seen can run also on x86. So it's quite easy to migrate because you just have to copy your files. So if you are running in the cluster, you can start your same applications that you are running on integrity. They will also run on x86. You don't have to do any recompilation or relaying of your application, just starting up. The only problem, of course, that is what we have. You have no native RDB yet, so we are still using the thin driver, the thin DGBC driver in our Java applications to connect to our RDB databases running on integrity. And then, of course, the native driver is not available yet, but I hope that Oracle by this year will also make RDB available on x86. Something about Java and the logical names. I must say, when you are running a Java application, sometimes it's not easy to get everything running smoothly. So there are some DXC logicals that we define so that the applications are running properly. So you have the DXC FD logging, we set that to true. If you want to have file versions, we set some Java flags. Also on the left side, you see the settings that we are using for our Java application. So it's always important. If you want to use file versions, you set some flags. If you want to look in your log files, make sure that they are shared, that you can look in it when your processes are running, and not only that you have to stop your process to look in your log files. And then as last, we always set a variable so that we enable thread dumps. Let's say there's a threading problem, that at the time you can force a thread dump of your application that you can investigate what went wrong. I must say, we use the same settings on x86 as on integrity. Yes, when you have Java applications, they are multi-threaded. One Java application can bring down your complete machine, so because it can consume all CPUs. So most of the machines are 16 core machines, and we make sure that the MCAT thread efficiency parameter that we set it to 4. So one application can maximum use 4 cores and not more, and most of the time it's sufficient. You also have the possibility when you start your application to add your kernel thread limit to 2. That is what we use because we have, let's say, 400 Java applications running on the same machine, and we say with 2 cores it's sufficient. For example, for Miber, there we see that we need 4 cores, but I think that's also normal because they are managing quite a lot of resources to run properly. But what is missing a little bit when we are submitting Java patch jobs via the batch queue, there you can't set any kernel thread limit. And also we are still using the scheduler. There it's also not possible to set any kernel thread limit, so it's using then the sysgen parameter. But it still would be nice that we could also set that when we submit the job. That's something for VSI to think about, I think. When we switch to OpenGDK, sometimes we have strange behaviors, and then we try to find out what it is, and then we played a little bit with this variable. It's a compile threshold. So when you are running your Java application, at a certain moment it will optimize your code, and standard it will only do it when your classes are invoked 10,000 times, but we had to put it to 1,000, and this is running much better. That's what we have noticed. If we don't set that parameter, we got strange array index out of boundaries exceptions. We got strange exceptions. We didn't have that in Java 6, but on OpenGDK we had that. But now we are redefining our Java symbol, and we had the compile threshold to 1,000. It's just it was, I think, for let's say 10% of the application that we are running, not all of them. Then Java and RDB. When you have a Java application, you need a JDBC drive to go to your database. We are using the native driver, but the problem is a little bit with RDB is that RDB, you will put a lock on a record. But when you have a Java application, you make a connection to the database. When there are many requests, it creates an extra connection to the database. And RDB, he can't see, he only can see this is a log from this process. And what we see when we are using the native driver and you have many connections in one process to your database, you get a lot of deadlocks. That's why what we have said now, when we have an application that requests quite a lot of connections to your RDB database, we are using the thin driver. And when you are configuring your thin driver for JDBC, you can say, I want to have one process with maximum one connection to the database. And this is for RDB much better, and you have less deadlocks. Because then RDB will see, okay, you request a log, the other one will wait, and then the other one will get a log. But when you, in one process, when you have a lot of connections to your database, you can create quite a lot of deadlock situation, and that's what we try to avoid. To do that, to configure your thin driver, thin JDBC driver, you have a configuration file where you can configure that. And you can see we set the maximum number of lines to 1. You can easily set it to 20, but then when you have one application creating a lot of connections to your RDB database, RDB will not recognize that sometimes you have to wait for each other. It will raise quite a lot of deadlocks. Then I did a comparison. I tried with some heavy Java applications, compare it on x86, and then also how it's running today on an i4 server. So you see we are running VMS on x86 on VMware. We have 8 cores, and on our integrity server in our development environment is an i4 server. And then I played a little bit with how many cores will I allocate to an application that is started on the OpenVMS platform. And what we see there is on the integrity server. So when you start up an application, Java will do a lot of class loading, and it will try to use all the kernel threads that it has available. And what I saw with an application that was quite heavy on an i4 server, when you give it one core, it took 133 seconds to start up. When you gave it 2 cores, it took 82 seconds. And then in the end, when it got 4 cores, it took 69 seconds. And if you gave it 6 or 8 cores, it was still the same. But then on x86, when you gave it 1 core, it took 286 seconds. When you gave it 2 cores, it reduces by 50%. And you see the best optimal solution on x86 for that application was given 6 cores. And then I think we are almost at the same speed as on integrity. So for us, what we think on x86, we need a little bit more cores, but I also think the hardware is cheaper. I think for us, we can move and migrate our applications from the integrity environment to the x86 environment. Then, of course, we have OpenVMS, but in the meantime, we have also Kubernetes platform. So if you look to this picture, so on the bottom, you see the OpenVMS servers and the applications hosted on the OpenVMS platform. And above that, you see our Kubernetes platform, where we also have APIs and some microservices. And then on top, you see our Oracle databases. So the Oracle databases, they are running on a Linux platform, but the applications on the OpenVMS platform and also on the Kubernetes platform, they go to the same applications. When it is RDB, then of course still the databases are hosted on the OpenVMS platform. So we have also applications running on the Kubernetes platform, accessing our RDB databases, but for the Oracle 90C databases, they are running on a Linux platform. So we make sure that when we have some new functionalities in the Kubernetes platform, we can also use them on the OpenVMS platform. When people create some APIs, we can also call them from the OpenVMS platform. And by doing that, we get one ecosystem that is running fine in a certain brand to fulfill the needs. Then also both environments, they are using MQ series for messaging. So the Kubernetes platform, but also the Java application running on the OpenVMS platform. We are using, I told you, Git to handle our source code in the Azure GitHub, but we are planning now to migrate to GitHub. Today we have a lot of things, repos in Azure DevOps, but still the plan is now also in Volvo that we should use more GitHub and go to that environment. And I told you the Java developers today, they release new Java applications, they just deploy running their pipelines, they don't log on anymore to certain servers. It's done automatically. Then I told you we have quite some servers running around the world, and then not to remember all the passwords of the different servers, we are using LDAP, so you configure ACME LDAP, and then it's easy to integrate with Active Directory, so you can log on the VMS servers with your same user ID and password like you use on your normal PC. And a lot of people ask, is it difficult to do? But there is a good help. I think the ACME LDAP standard config install document that you can find with system or help. If you just follow that, then it will work for you as well. Yes, yeah, I'm walking around. Is it still interesting or is it too complex? Then Oracle 90C. You know, on OpenVMS, it's only Oracle 11 client that we still have, but Oracle 11 is supported, that client, with Oracle 19C, which is running on a Linux platform. And so if you log on with SQL Plus, you'll see you are still using Oracle 11 client, but it's working perfectly together with Oracle 19C. Then on x86, there we are testing our SQL Relay Server. So I showed you our Kubernetes platform. We installed an SQL Relay Server in a Docker image on the Kubernetes platform. And from the SQL Relay client along with VMS, we can also access the same databases. What is missing at the moment, I think, we have still some Fortran applications, the embedded SQL in our Fortran application also supported by the SQL Relay client. I think Pascal is supported and COBOL, Fortran not yet. And of course, I still hope that Oracle will also make Oracle client available on x86. If not, then we will use the SQL Relay client. Yeah, smart manufacturing. Today we are talking a lot about Industry 4.0, Industry 5.0. They are even talking about Industry 6.0. What is now the difference? Do you know what the difference is between Industry 4.0 and 5.0? In Industry 4.0, everything should be automated. The data should work automatically. What they forgot a little bit in Industry 4.0 was the people. And now they say, we have an Industry 5.0. We still need people that can also decide, yes, what my machine learning model is proposing, yes, this is what we should follow. You still have people, and you should not forget that. So Industry 4.0, very good, I think, a good things that are changing, but you still, people are still important, and you should not forget that. So if we look to our data strategy that we are using, and today, you have a lot of standalone applications. You have your ERP system, where you define your orders, your material. You have a PLM system, where we define the bill of material of the car. Within Volvo Cast, we are using Teamcenter, and we have our MES solution. So daily we get the orders from our ERP system to our MES system, and we get the bill of material from Teamcenter, and then we know how to produce that car and what information to send to our SCADA solutions and PLC solutions, and the PLCs are communicating with all the equipment behind the PLCs. So it was more standalone applications. What we see also today, and what we are working on, we want a full integrated solution between our ERP layer, so we will use S/4HANA for that, our Teamcenter PLM layer, that is something owned by our R&D department, and then our MES layer that is running on the OpenVMS platform. There we want the full integration and the real-time integration, not this daily, you get this information. Now, when we need information, we should be able to share it. What we also see, if we integrate more what we do today, we also need more security. So what we see now, we get much more firewalls. We have to secure our data, our servers, because we start to communicate much more and also more real time. Also with our OT equipment, the equipment in the plant. So we have the IT equipment and the operational technology is your equipment in the plant. But we also see how we start to communicate more and more, and we have to protect that OT environment. When you install a factory, you install robots, you install PLCs, but they are installed and you can use them. Robots you can use for 30 years. So if you install equipment, it will be there for quite some time. So you have to make sure when you have some older OSs in the plant that you can protect them from the internet so that they are not hackable. When they install new equipment today, we do cybersecurity assessments. We really verify is it compliant from the supplier, and we make sure that we follow the rules. So it's not allowed anymore to enable every protocol or public SNMP. So we try to do it in a proper way. What we also see more and more now, we want to collect more data from our equipment to do predictive maintenance. So we start also to use more OPC UA. In the past, we had a lot of socket communication, but what is happening now, a lot of suppliers delivering equipment, you can collect data from these machines using OPC UA. And I think in the near future, everything will be connected. So no difference between IT and OT anymore. Everything will be connected, any-to-any communication. And also what you will see then, today, sometimes you have a robot that is working, and suddenly there's a problem. What we are doing at the moment, absolutely, we have 900 robots. We are collecting all the data that we have from the robots. We are collecting that, sending that to our big data platform, so that we can predict when we have to do maintenance. Today, it fails. We say, okay, if we had measured this resistance value, or that the robots are to consume more electricity, then perhaps we have to do maintenance earlier and then avoid the production stop. So this is coming more and more. We get more requests to collect more data, but then you have your equipment data and you want to combine that with your MES data, with your logistic data and your quality data. This is what I showed you. We have a nice integration between Teamcenter providing the bill of material, which parts do we have in the car, the bill of process, how to assemble the car, the instructions. We send that information to S/4HANA, our ERP layer. We have the orders. We send the orders to our castle. That's the name of our MES solution. And the S/4HANA solution will say, you have to build this car with this bill of material and this bill of process. We just execute and we report back when it is finished. And then we also have the bill of equipment. Today we are not using that to the full extent, but also there we think if you define everything in advance, you also know we have this equipment in the plant, then we also know which instructions to send to that equipment, because today we make a lot of integration to different equipment, but also we think when we configure everything in advance, we just can use it. And don't today a lot of instructions are reconfigured in the MES layer, when we can configure everything in Team Center, get the orders from our EEP layer, and we just execute. There's something about, I told you, we try to collect more data from our robots. Also, we get also a lot of cycle time information from the PLCs, also alarms. We also collect data from RFID readers. How many no reads did we have? How many times did we have double reads? We are also installing now, in the past we did a lot of welding. So when you at the welding shop, you get your steel and you weld everything or glue everything. But nowadays we have a new process called mega casting. You order aluminium, you put it in a big machine, you melt it, put a mal on it, and your rear floor will come out immediately without any spot welds. So mega casting is also coming. Tesla started with this, but also Volvo has decided to do more mega casting. I would say it's a big machine. I was impressed, but it's quite good and quite strong when your floor is coming out of the mega casted machine. Then I told you I have quite some nut runners where we collect data, pick-to-light systems, and also HFX. All this equipment we connect with a layer called virtual device. So we have a small Java application called virtual device. In virtual device, you can plug in any driver you want, and then you can communicate to any equipment in the plant. Then we try to send the IoT data to our data platform. We have a data platform called Smart Facts. It's a self-service platform. So any maintenance technician that wants to collect data, in fact, can set it up by himself. He just say, I want to collect this data from this equipment. He gets an API key and starts to send the data to our data platform. He orders an AD group, which people should have access the first time when he's sending the data. Automatically your schemas and your tables are created, and he can send the data to the data platform and analyze the data for what he needs. What we are also doing, and of course, we have our real-time management solutions, we have our quality solution, we have our MES solution, and we have also our plant maintenance solutions. We are also trying to send also that data to our data platform, and by doing that, we hope we can create digital twins of every process, of the welding process, of the paint process, the battery assembly, the final assembly, or you create a digital twin of an installation. But by doing that, what we are trying to do now, make sure all the data is available so that we can analyze it. You still can follow? Yes. Oh, sorry, I have to go here. Then I told you we are using more and more our data, but what we also are trying to do now, trying to use also some machine learning in the plant. Today, we have a lot of inspections. Sometimes, this is a simple example. Sometimes people have to check is the correct tread plate. When you open the door, you can have a tread plate on your door and it states Volvo or Recharge or Polestar, because we are also building some Polestar cars. And on some cars, you should not have a tread plate. It's very simple solution, but today a person is manual checking. And we said we should do that with a camera. So we bought a camera, €300. We installed that line. And we know which car is arriving, because that's in our the PLC knows that. We get that in our MES layer. So when a car is arriving, we track the camera, we take 3 pictures, and then we analyze is the correct tread plate on that car. But before you can use a machine learning model, you have to train that. But we produce 1,000 cars a day, so with 1,000, and we take 3,000 pictures, you train your model. So your model is trained, and then you can start to use it. So what we do, cars arriving, we trigger it, we take 3 pictures, then we have a machine learning model. That machine learning model can ask our MES system which car it is and which part should be on that car. Then the machine learning model is checking is the correct part mounted on that car. If not, we create automatically a quality item in our quality system. So what we are trying to do now is replace the manual inspection with computer vision cases using machine learning. And what we have also seen in the past, we installed a lot of vision systems, but then we bought expensive solutions. And then every time when we had a new car model, the supplier had to go on site, retrain the model. What we are doing now, that the people in the plant, we will train them that they can retrain the model themselves, so that we don't have to go to a supplier to come on site to do this. So for the moment, we only have to buy a camera. We have a machine learning platform that we also use for our cars, and we start to use it now also for our plants. So we can train our models, and the people in the plant depend that they do it themselves. So then everywhere when we have manual inspection, get to computer vision inspections, and also link that to our MES layer. And this is also ongoing. Yeah, then here, so that is the use case, end-to-end framework for image classification and fault detection. Then we integrate it nicely with our MES layer. And then what is then the result? We can reduce the labor costs and correct errors before the cars leaving the plant. So of course people can also manual check with what we have seen, also in the welding shop. When you have a robot or a computer vision solution, it's always better than human checks. That's how it is. A person is of course good, but sometimes you forget things, and we think we should go more to quality inspections using cameras fully integrated with our MES layer. Then I talked about data collection. So I told you we have a self-service platform. We can send our data. If we want to send our data to our data platform, we can do it using REST APIs. We can do it via MQTT, or we use Kafka. Kafka we use when we have a lot of data, when it's a high data stream. Then we have seen, then it's best to use Kafka, you get more speed. And then we bring the data to our data warehouse, and our data warehouse is based on Snowflake. In between, we have a data lake. We have a data lake in AWS, but we are in multi-cloud, and within Volvo cars, we never can decide what to use. So we have a data lake in AWS, but also in the Azure cloud. And from there on, it's forwarded to a data warehouse in Snowflake. Yes?
It is time for the next session.
Yeah, this is the last slide. So what we are doing now to send data, I've seen there's no Python available, so we are using Python to send the data. Also, we have quite some data on the RDB database, so we are also using Python now on the OpenVMS platform to send data to our data platform. It's important when you are using Python, make sure everything is UTF-8. You have to use, you can't just take your data from your database, you have to make sure you translate everything to UTF-8 format. And today, we are sending our data from RDB to the cloud using some JSON formats. And at the moment, we are sending, perhaps say around 10 million records daily from RDB to Snowflake using Python. And so I would say Python is a nice solution for data handling, really good. So we have to make sure we get also new Python releases available on the OpenVMS platform. Yes, now I'm on the end. It was a lot of different things. I hope it was interesting. If you have more questions, you can come to me. I hope it was interesting. Thank you very much.